Okay, hello everyone. Today we're going to see inverse theorem part 4. Okay, let's get started. The first question: superposition theorem is applicable to. Okay, the options are voltage, current, both current and voltage, current, voltage, and power. Okay, superposition theorem is not applicable to power. It's one of the important question. So there is no power here. Only voltage and current is the right answer. So the next one. Superposition theorem can be applied only to the circuits having. Okay, superposition theorem is applicable to the circuits having linear bilateral elements. Okay, it is definitely a linear circuit. Okay, then only the superposition theorem is applicable. So the linear bilateral element is the right one. Next question: for a voltage sources, terminal voltage is always lower than source EMF, or terminal voltage cannot be higher than source EMF. Source EMF and terminal voltage are equal. Okay, so for voltage sources, the terminal voltage is always lower than source EMF, because some resistance are there in source. Okay, so the terminal voltage is definitely smaller than source EMF. So the option A is the right one. Okay, next one statement, we have to find which theorem it was. Okay, any number of current sources in parallel may be replaced by a single current sources whose current in the algebraic sum of individual currents and source resistance in the parallel combination of individual source of resistance. Okay, so the current sources in parallel with the resistance. Okay, uh, sum of the resistance. Okay, so this statement is resembles like Millman's theorem. Don't confuse with Norton's theorem. Okay, if the given was voltage sources or current sources and parallel with the algebraic sum of source resistance, sorry, individual source resistance, means it's a Millman's theorem. Okay, so option B is the right one. The next question: for high frequency transfer of power, internal resistance of the source should be, for high frequency transfer of power, the internal resistance should be less than load resistance. Okay, it cannot be higher than the load resistance. So option B is the right answer. The less than the load resistance is the right one. Okay, next question: for maximum power transfer, internal resistance of the source should be, for maximum power transfer we knew that internal resistance should be equal to load resistance. So option A is the right one. So the next question: in a series parallel circuit, any two resistance in the same circuit path must be. In a series parallel circuit, any two resistance in the same current path. If the two resistance having the same current path, means it is considered to be series. Okay, not in parallel. So the option A is the right one. And the next one: application of Norton's theorem to a circuit yield. Okay, Norton's theorem is look like equivalent current sources and impedance in series, or equivalent current sources or impedance in parallel. Okay, don't go to the another option, because option B is correct. Current sources in parallel with impedance is the right one. Okay, the next question: in Thevenin's theorem, to find Z. Okay, if you have to find Z or R Thevenin, means what we are going to do in for current sources and voltage sources. Okay, so first option, all independent current sources are short circuited and the independent voltage sources are open circuited. Okay, we don't go to the another option. The first option is right. Okay, independent current sources will be short circuited and independent voltage sources will be open circuited. Okay, so option A is the right answer. So option A is the right one. Okay. That's all about today. If you have any doubt in this question, please write it down in the comments below. I hope you learn something about my lecture and videos. Thank you so much for your support, and thanks for watching.